This is the lecture for lesson 35. In this section, we are going to be working with matrices, talking about matrices first, and then eventually solving our systems with matrices. So this is what a matrix looks like. It's going to be a bunch of numbers inside of these brackets. And the first thing we're going to talk about is the dimensions of the matrix. So the dimensions of the matrix are always the number of rows by the number of columns. So if we look at this first matrix here, I have 3 rows and 2 columns. So this matrix is going to be a 3 by 2. The next one here has 1 row and 2 columns. So the matrix is 1 by 2. Then inside of each matrix, every single number represents a place or a element, and that element is based off of its row and column location. So if we are asked to find, say, A2, 3, that's saying find the element in row 2, column 3. So rows are always first, whether you're talking dimensions or elements. Columns are always second. So I would find the element in row 2, column 3, and that is 7. So this first matrix A, we have the elements 1, 2, 3, and then 4, 5, 6. We want to describe its dimensions first. So if we look at it, there are 2 rows, and then there are 1, 2, 3 columns. So the dimensions of matrix A is a 2 by 3. The next thing they want us to do is list all of the entries. So A1, 1. So that's the first row, first column is element 1. So then I'm going to go A1, 2, first row, second column is 2. A1, 3, first row, third column is 3. Now to do the next row, it's going to be A2, 1, second row, first column, 4. A2, 2, second row, second spot, 5. A2, 3, second row, third spot is 6. Looking at the next matrix A, we have 3, -6, -6, 8, -2, 1. What are its dimensions? Well, we have 1, 2, 3 rows and 1, 2 columns. So 3 by 2 is the dimensions of this matrix. And they want us to find the element 3, 2. So row 3, column 2, that is the value 1. Now that we understand what a matrix looks like, now we're going to go and turn our system of equations into what we call augmented matrix, and then work with that matrix to solve our system. So the first thing we're going to have to do is talk about how we create what's called an augmented matrix from our systems of equations. And what an augmented matrix is it takes all of our coefficients in front of our variables as well as our solutions and puts them into a matrix. So if I look at this first equation, 3x minus 2y plus 5z equals 31, the way I'm going to start this matrix is I'm going to need a row with 4 columns because I've got an x, a y, a z, and a number. And looking at the rest of these, I have an x, a y, a z, and a number, an x, a y, a z, and a number. So when I do that, I have 3 equations, and I'm going to put their coefficients of the x's. So 3x, then there's a -2 in front of the y, a 5 in front of the z, and then 31 is the answer. And an augmented matrix usually has this little vertical line here separating the variable pieces from the solutions. Next one has a 1 in front of the x, a 3 in front of the y, a -3 in front of the z, and a -12. Next one has a -2 in front of the x, a -5 in front of the y, a 3 in front of the z, and an 11 as the solution. That is my augmented matrix. Looking at B, I have x minus 2y plus 3z equals 9. Then I have y plus 3z equals 5, and z equals 2. So you're probably already looking at this and saying, okay, well, they don't all have an x, a y, and a z, so what do I do? Well, we're going to follow that same process, x, y, z number. So there's a 1 in front of the x, a negative 2 in front of the y, a 3 in front of the z, with an answer of 9. Now in the next one, there are no x's, so I'm going to put a 0 for x. There's no x's. In front of the y is 1, in front of the z is 3, the solution is 5. Then in the last one, all I have is a z. So there is no x, no y, 1 in front of the z, and the result is 2. Looking at C, we have x minus 2y plus z equals 10, 3x plus y equals 5, 7x plus 2z equals 2. So same process, 3 equations, 3 variables. So 1 in front of the x, negative 2 in front of the y, 1 in front of the z. The answer is 10. If you're missing a variable, you put in a 0. We have a 3 for an x, a 1 in front of the y, no z, so 0 equals 5. 7 in front of the x, no y, so 0. 2 in front of the z, and then 2. What we're going to do is take our equation, like we just did, put it into matrix form. And we're going to use this process called Gauss-Jordan elimination method so that we can get to our solutions. Our goal is that we want 1, 0 number, 0, 1 number, because then the top is what the x equals, and the bottom is what the y equals. So what we have to do is we're going to use some operations. We can multiply rows, we can add or subtract rows, we can swap rows to be able to get to the solution that we want. Now, we want to get 1, 0 number, 0, 1 number. That gives us a solution. If we get 1, 0 number, and then in the bottom row, we get all zeros, this is an infinite solution or a dependent that we've seen previously. And that's the one where we're going to have to write x in terms of y or y in terms of x. The last option is where your bottom gives you 0, 0, and number. That's saying no 0 for x, 0 for y still gives me an answer, which is not possible. So this is our no solution option. And this is our inconsistent system. All right, so our first problem we're going to use Gaussian elimination for is 2x minus 8y equals 3 and negative 6x plus 24y equals negative 6. So the first thing I'm going to do is turn this into a matrix. So 2, negative 8, 3, negative 6, 24, and negative 6. Your first step is to get a 1 in this upper left spot. So in order to get a 1 there, what I'm going to need to do is I'm going to need to divide everything in this first row by 2. So divide everything through by 2. So 2 divided by 2 is 1. Negative 8 divided by 2 is negative 4. 3 divided by 2 is 1.5. And I'm going to leave the bottom row as is. Negative 6, 24, and negative 6. Okay, so step 1 is you want to get a 1 here. Next step is to get a 0 underneath it. So step 2, we want to get a 0 here. So to get a 0 there, what we're going to do is we're going to multiply and then add. So here's what I'm doing. I'm going to take that row that I got a 1 with, and I need to figure out what's going to cancel out of negative 6. Well, a positive 6. So what I'm going to do is I'm going to take row 1 times 6 and then add that to row 2. So I'm not changing the top row. I'm only changing the bottom row. So if I do this first one here, negative 6 times row 1 is 6. 6 times 1. And then plus row 2, negative 6. That gives me 0. All right, now I'm going to do 6 times the top value. So 6 times negative 4, add the row 2 value, 24. Well, that's negative 24 plus 24 is 0. And then do the same with the end one. 6 times 1.5 plus negative 6. Well, that's 3. 3 plus negative 6 is negative 3. So I got my 0 there, but if I look at this bottom row here, this is saying 0x plus 0y equals negative 3, which is not possible. So there is no solution to this equation. Next one, we have 5x minus 4y equals 34, and 2x minus 2y equals 14. So I'm going to start with what I have here. 5, negative 4, answer 34. 2, negative 2, and 14. So our goal is to get that 1 in that top left corner. What I see, though, is if I want to divide all these by 5, it's not going to work very nice. So what I'm going to do first is I'm going to swap the rows. Because I want to have nice numbers. I don't want to be working with decimals. So I can always flip-flop the order. Okay, so step 1 is to get a 1 up in this corner. And I can do that if I take every single piece in that first row and divide by 2. So row 1, divide everything by 2. So that's going to give me a 1, a negative 1, and a 7, leaving the bottom row as is. So I'm only working one row at a time. So now we have our 1 in that first spot. The next step is to get the 0 down here. That's step 2. We do that step by multiplication and addition or subtraction. So let's see, if I have 5 here, the only way to get rid of a 5 is if this is negative 5. So I'm going to take negative 5 times row 1 and add it to row 2. So the top row is going to stay the same. And I'm going to do each piece as I see it. So negative 5 times the row 1 value is 1, add 5. That's the row 2 value. That gives me 0. Now I'm going to do the next column. Negative 5 times negative 1, and then I'm going to add negative 4. So that's 5 plus negative 4 is 1. And then next one, negative 5 times 7, and then I'm going to add 34. So that's negative 35 plus 34 leaves me with negative 1. All right, so your next step, step 3, is to get a 1 down here. Well, hey, we already have a 1 there, so step 3 is taken care of. So we don't have to do anything for step 3. Step 3 is as is. How would I do that if I needed to? I could multiply or divide by a number. If this was 2, I would divide everything by 2. Last step is to then get a 0 up top here. So we literally start in this upper left corner and make like a U shape. So we go down, lower left, then lower right, and then do upper right. So to get that one, we're going to figure out, well, right now they're already opposites, so I can just add the 2 rows together. So I want to change row 1. So I'm changing row 1 by adding row 1 and row 2 together. I'm putting that in row 1. That one was down here for row 2. So row 2 is staying the same. I'm changing the top. So let's see. Row 1 plus row 2. Well, 0 plus 1 is 1. 1 plus negative 1 is 0. And negative 1 plus 7 is 6. Once I have gotten to this form, I have my answer. This first row is telling me x is 6, and the second row, y is negative 1. So our solution is 6, negative